All right, I think we can start. So welcome everyone to our last lecture in Node.js, part of the Rolling Scope School. And today we're going to look at something rather important, important to get right, as well as important to understand if it's too complicated to get it right. So, and this is authentication. In general, and some of the topics in particular, like security and courses. This is, again, me. And our today's agenda will be to look into several different topics, all around that authentication process. First will be the authentication versus authorization and various different ways we can achieve that. In particular, we'll look into passport and JWT. Then we have security, and then course, which is might be familiar to some of you, rather annoying, I believe, to some of you, and that's what we are going to cover and understand why we're getting those errors in the first place when developing, for example, a front-end application, and how do we really handle them in Node.js. So we'll start with a small discussion of what is authentication. How is this particular word, authentication, is related to a similar sounding, for some people, word, authorization, and how they're different, how they're related. And my first example would be something abstract. It's not related to any particular solution. It's not even framework specific. It's something that we tend to have in terms of authorization, authentication in any system. So let's imagine that we have some kind of API in the middle. So in our particular case, it's called API gateway. And the gateway part means that it is the first thing that we hit when we're dealing with a possibly larger set of servers, but this is a gateway, like a tipping point for the whole system. So then we have API client. It could be a real machine running another service. It could be our own laptops and PCs, so web browser clients. Actually anything. The only thing that we focus here is that we have an API in the middle and something is consuming that API, and the consumption part is called client part. Then we have on top of our API gateway, right at the top of the diagram, an API key registry. Again, nothing specific, not related to any database solution, to any particular framework or library that does that. It's just a place where we keep some kind of key registry or key list that we issued, and we just want to make sure that we know which one we're kind of like giving and whose requests we're letting through. And then API endpoints. Again, on the right side, there will be some kind of abstraction on top of any microservice or third-party service or any server solution, maybe a monolith, and we're accessing a different part of that monolith. Don't really care what that would look like. It's just API endpoints in our case. So, and this, like, three different parties, they're all kind of work together, and the orchestration of that work is API gateway related. So API gateway being our authorization authentication system, kind of handles the communication between API client and API endpoints. So when API client makes a request to an API gateway to our backend, first time it does that, we need to understand, do we know that client? So, and this is the request that we get from that client, saying that, hey, the client wants to get some resource. Here's an API key, some kind of authorization or specific key that client thinks would get the client access to our API endpoint. So essentially, client wants to get this request all the way through our API gateway to some kind of API endpoints. It doesn't really need to know that there is an API gateway. It doesn't really know which API endpoint will handle that or where that API point located. All it has an HTTP word or verb, an API resource URL, some kind of protocol notation, and it knows that in order to access that private resource, it needs to give some kind of credentials in any given form. In our case, that would be an API key. So since client accesses that for the first time, it's called authentication. So authentication is the process that will go inside an API gateway. That's the logic there, that will determine whether we know that client. So to kind of finish up with the example, we take that API key that we receive from the client and we match it against the key registry to know, did we actually issue that key? Do we recognize the key? Do we recognize this client that sends that key? Was everything with the request correctly set up so that we can recognize it? So it's called the API key validation or any kind of token validation. If we know that client, authentication is successful. Next, we kind of need to let the request through our own system to a particular API endpoint, kind of proxy that request. Since we already know that the client is someone we trust, we try to forward that request, but that's the second part of any kind of authentication authorization system, and that's called authorization. Even if we know the client, even if the client has access to our API gateway, the client not necessarily has access to a particular endpoint or particular service. So this request might fail. And that check, whether it will fail, whether the client has access to a particular API endpoint or not, is actually what we call an authorization check. So kind of to reiterate, authentication is we determine whether the client is known to us. And authorization, we determine whether the client has access to some point or endpoint or some service. And that's two different things. Might be confusing from the get-go, but if you think of it, there are many API kind of endpoints, handlers, routes, or think of it as any particular resource. There are many resources in a server. So to kind of know and separate who can access what resource, we need to have a process, an authorization process. So one client can be known to us, but that could be just a regular client, a regular user. And that user will have access only to GET requests or GET resources, for example. An admin would have the same authentication process. So admin will have the same authentication check. We know the admin in the key registry. However, the admin would definitely pass all the authorizations because that admin will have get, post, delete, put, patch, all those requests, and all the different API endpoints would have kind of access to, or the admin will have access to all those different kinds of endpoints. So it's two different processes. We need that kind of understanding to move forward. So if you have any questions so far, please leave them in the chat. If not, we'll go to the next slide. So that was a bit too much, I think, already. However, to simplify the process of authentication, authorization, etc., overall, to simplify the access control in Express, some really smart engineers came up with a Passport.js solution. It's one of the most used solution, but it's still one of, meaning that there are many ways to organize the same flow, kind of checking whether we have access to something, whether we have access to the server itself, and whether we authenticated, and whether we authorized to do something. So again, just to reiterate, authentication is about who accesses the server, and authorization is all about what someone accesses. So going back to Passport.js. So Passport.js is just a library, and it's written in a way of being able to follow middleware pattern in Express. So it's just an authentication middleware. It's extremely flexible and modular, meaning that the whole process of authentication authorization could be done using various different solutions, or either written from scratch or provided by industry well-known providers like Facebook, Twitter, Google, etc. So we can just steal, so to say, so just copy the solution from Google or Facebook, etc., plug it in Passport, then plug Passport with that solution into authentication middleware, and voila, we have a working authentication using that particular flow. Or in Passport.js vocabulary, it's called strategy. And you might be already familiar with different design patterns, since we mentioned middleware being a pattern in the last lecture. Strategy is another well-known pattern, behavioral pattern, and that pattern states that strategy, being Passport, could be internally switched to different kinds of algorithms, Google, Facebook, Twitter, etc., to provide same functionality, but with a different approach. So Passport follows this strategy naming. How do we use it? So we require that module Passport to kind of get the framework of authentication. We initialize it. We configure like its own configs and at least one strategy. So whether we want to have our custom written strategy or whether we want to use the Google, Twitter, Facebook, etc. ones. Then we specify where that authentication middleware should be applied, whether it's an app level or whether it's this particular root level. And that's how we protect the roots. This is the same what I just said, but in a code way. So as you can see on the left, we have a setup thing. We essentially say passport.use, so has the same kind of, it follows the same architecture internally as a typical middleware application, Express application. And we just provide a specific instance of that strategy. So new local strategy will be the one that we write ourselves. So as you can see, there will be new local strategy returned, return an instance where the callback, one of the parameters of that local strategy configuration, would be the actual middleware would be used every time we access that particular route. There is also a bearer strategy. At the same time, as you can see, we can use that as well. So, and we write less than that. So in the local strategy, it's usually username, password based. So credentials should be provided in a way of username and password. In a bearer strategy, as one of the authorization headers, we need to provide token. And that actual token would be the one that we mentioned on one of the previous slides, where we check whether we know that token, going and looking for that token in our registry. And then if result is undefined, as you can see, we say that, hey, authentication failed. And in success case, we proceed with our authentication. Whereas in the username password, it's almost the same, just that username and password, they're used to kind of find an employee in some username database based on the password, and we use that to find that there, again, that abstraction of the key registry or user registry. And if we find something, we're done, we authenticate it, and the request proceeds to a particular controller. However, if we don't find any user or user last name, for example, doesn't equal the password, it could be anything here, but still, that's kind of like what we decided for our authentication based on. We're saying that, hey, authentication is not successful and there is a message. So this is how we store users. So as you can see, last name, first name, password. And so in this case, I would need to provide, as part of my authentication process, username and password to every request. In the bearer strategy, we need to provide a token with every request if we want to authorize against our backend or API gateway. And that's how we connect what we've written on the previous slide with actual Express endpoints. So imagine I have an API.post endpoint. It'll be /authenticate, meaning that I intend this endpoint to be used as a way to authenticate user. For example, in our case, we say that, hey, we authenticate using local strategy without keeping the session. And if that authentication is successful, we provide a token back, and that token will be used as a bearer token in any requests that follow. So in this case, as you can see, we're setting out the local strategy. We expect the username and password should be provided. If we find that information, then we're successfully returning the employee as part of our local strategy. And in the bearer token, we expect a token to be present. So something similar happens here. So our endpoint to authenticate will generate a token based on our user. In the most simplistic way, it would be just something like that. We'll push the token when we generate that to kind of save it in the key registry, and then we return it so that users could actually go and use that with every request. And then we say that I want to get employees endpoint to be authenticated using that bearer token, and I expect users to actually provide them, because I'll be looking for that returned token or any that I stored in my key registry. That's kind of like the basics. And as you can see, once I've written all the strategies that I want to use, the only thing that I need to do passport related is to add password.authenticate with some configuration to every endpoint I want to kind of protect with that authentication, the particular strategy. And that's the strategy switching part. So I say local, internally the authentication passport user switches to local strategy. so to this one. If I say bearer, it will switch to bearer strategy. That's how the strategy pattern works. And Passport.js is a good example of that strategy pattern. So just to summarize, we post requests to the authenticate route with data in the body, as we've seen. We expect that to be somewhere in the request. And in particular in the user, request.user, and that user will appear there as part of some other middleware logic. As a result, we get the JSON token or JSON ID in a token. It could be anything, not necessarily JWT that we'll discuss later. It could be just some random piece of unique UUID. And then that token should be used with every request, in particular GET request to that protected route will be using the bearer token somewhere in header, authentication header. This is what this part describes. And that's the most basic flow with Passport. So as you can see, we're not writing a lot of logic ourselves. And the cool part about Passport is that instead of just writing our local and bearer strategies and kind of handling the authentication, finding whether the user is actually authenticated and whether we know that user or not, is handled by ourselves. Instead, Passport, with this kind of flexibility, provides us with ways to authenticate against Google accounts, Facebook accounts, Twitter accounts, and many more. So it's kind of like having Passport for different countries, but instead of countries, we have different authentication providers. And that's it for the Passport.js. And we go to a different popular solution to organize authentication and authorization flow in Node.js applications, and that's JWT. Okay, so before we move on, again, I'll ask you if you have any questions, please slip them in the chat so that I can see, because this topic is actually pretty hardcore. And it's really, in a production project, it comes down to not how we do authentication, but whether we want to do authentication ourselves or not. And with Passport.js, we kind of rely on the solutions that have been written already for us by the people, by Google, Facebook, Twitter, etc., and we do the minimum amount of work, because you don't want to get authorization wrong in your application. So whether kind of like a rule of thumb is to have authentication handled by a third party. For example, Google is a popular solution. So Passport.js is only for authenticating? No. Since we know the difference between authentication and authorization is a bit vague, but it is for authenticating users. So as you can see, this part is about authenticating and giving back the token, and about authorization. So authorizing users to access a particular endpoint. So that's kind of for both ways, to authenticate someone, kind of to get to know someone, and then authorize someone. Let that someone do something with your API. So just keep in mind that there is a difference in this two processes. Passport could be used for both of them. Passport is essentially what we kind of use to get both of the flows and kind of forget about it. All right, so let's go to JWT. So what is JWT? It is a basically JSON web token. The first part, JSON, states that somewhere in that token we can get the Well, very familiar format that we use in JavaScript, which is JSON. And what you're looking at right now is just a screenshot of the official website for JWT. And it's showing you different parts that combine get you the JWT. So on the left, you have an actual token, and on the right, you have kind of decoded parts of the token. So not to get into nitty-gritty details, all you need to know about JWT is that it contains some information. It's not just a random piece of alphanumeric values. It contains information, so you store something inside, like a payload, sub ID, name, and admin true. But it also has some predefined parts. It says which algorithm should be used to get that data. It has some signature part that will be kind of salted, and all those crypto words thrown in here to define the verification signature. But in essence, the JWT itself will be separated by dots to kind of denote whether one part ends and the next part starts. As you can see by the color, which that website, JWT website provides you with, by the color, this is the one that the payload contains. And that's kind of the most important for us. So whenever we generate the tokens somewhere in our code, and instead of generating it using UUID, so pseudo-random alphanumeric values, we generate it using some kind of definition, and JWT is essentially that definition. There are some important differences in the types and the algorithms that are used to decode or encode JWTs. But essentially, the key takeaway is that this is not a random number. It could be divided into several parts, and one of those parts will be your payload. They'll kind of fill in before generating the token. So, and like the other side, the one that will be using your token, will be able to decode it back to the original one and get the payload out using a particular algorithm, usually the same in a particular time, JWT. The signature will be used to kind of like make sure that it has not been tampered with, basically. So how do we work with those particular JWTs? As usual, as we've already seen with Passport.js, to kind of authenticate or authorize ourselves against a particular endpoint that we're interested in, we need to authenticate ourselves against that API gateway or that server. So the first part is usually authentication. And once we're done with authentication, we'll get the token and we'll authorize against every endpoint that we have access to. So first, post to users/login or any endpoint that you specify with your username and password usually, or some other credentials. In turn, that username and password will be fetched and validated against some registry or some database to kind of know whether whether this person is known, this username and password is known to the server. If it's okay, the validation is successful, we create a JWT token with secret part we discussed to kind of verify it later. We returned to the browser that requested the JWT token or requested the authentication. And at this point, authentication part is complete. Every request that follows to every resource that we have access to will be kind of set up to send authentication or authorization header. And that value inside that header would be actually our JWT. The logic on the back end will expect that authorization token to contain some value. It will retrieve that value, check the signature, get the information from the payload, do some nasty stuff with it, and send a response to the client. So that's how it works. So going back to that previous picture that we have in the beginning, after we get the information, after we do the authorization stuff, and find if the user has been authorized to access this resource. If it is successful, we actually fetch that resource and send it back to the client. So that's how it works. Essentially, the process is the same as with Passport. It's just that the creation of the token, sending it back, checking the signature, it's all now handled and by ourselves, and it is our responsibility. So as you can see, the code that we need to write is a bit bloated, this example. So it's the same authenticate/authenticate post request, and the controller is actually typical, your typical controller for any endpoint. It's not a middleware anymore, at least in this example. We authenticate. That means we're in authentication process. Authentication part, we need to find that employee, if we know that or not. If we know, we generate the payload, employee sub, ID, title, and then we sign using the JWT library and method sign. We provide the payload, we provide the secret, and the secret would be specific to our server, and usually we'll sort out in the environment variables. It could be a pseudo-random, it could be some specific sort-like value, string. But anyway, it's for us to know whether we are receiving a token that actually was generated using our service or not. We provide that secret. We set the expires in, which is a special notation that could force our users to re-authenticate to provide the credentials again, so that our token is not used indefinitely. And then we send it back. And then we create middleware that will check every time it receives the token. We'll check the token against our registry. So check token middleware. You can see it's written by us. It is our responsibility for it to be correct. And then we, just by setting a middleware part for every route, for every endpoint that we want, we kind of force or protect our endpoint with that JWT token. And the middleware part itself follows, I think, a predefined and common way to do the authentication with JWT, which is get the token somehow, check if the token is present. If not, send the unauthorized status. If token is present, verify that token. So provide the token, provide the secret that is internally stored in the environment variable, probably, and provide a callback that will have an error if the token is not valid or validation of that token is has failed, or proceed with the request if everything is okay. So the place that could vary, or depending on project, is probably where we store the token. Could be the X-axis token header, it could be the authorization header, or any other headers, any other ways that we store and provide the tokens. Logic will be similar. The way that we handle and what we do with the request and the token itself could be different, but the whole flow is essentially, again, our own responsibility. If we get some errors here, if we get some bugs here, the authentication will be flawed. And that's one of the cons of JWT. So one secret rules all tokens. As I mentioned already, we saw that environment in the environment variable, and that's true, that one secret rule will be provided for all the tokens. Revocation of tokens, hard to implement, is another one on top of what I just mentioned, with our own responsibility of writing this logic. But revocation of tokens is something that we cannot control using some kind of expires in thing. Expires in will automatically specify somewhere in our registry that this token is no longer valid. But if we want to do that before that expiration time, that would be hard. And it will require us implementing that logic ourselves. But pros is there's no server-side storage compared to any other authentication method. We're just storing that secret. We're basically relying on JWT signing that correctly. So as you can see, there was no logic when we actually stored anything. We're verifying, we're signing something. So going back to any passport or any custom solution, there is no need for key registry to compare that against. We need to have just user registry to kind of keep track of all the users that are using our application, but that is probably what we already have for other purposes. But for the tokens themselves, there is no registry, and that means that it cannot be violated. Easy to use, a lot of libraries kind of fork from it. Can be used across services, can be encrypted for extra security. That's all the pros, but essentially with JWT you get less handled by someone else of the authentication authorization, meaning that you do most of the coding yourself. But pros are also cool, to have no server-side rendering storage. So keep in mind that authorization authentication is always a hard topic, and it's better to rely on some ready-made solution to get that authorization authentication. Otherwise, it's prone to have bugs, and those bugs will essentially get you some security violation things. There is a topic that I need to mention in terms of the authorization authentication, which is the difference between access tokens and refresh tokens. It is cross solution wise, meaning that some tokens, it could be JWT, they could be different tokens, or any user generated or server generated tokens using other libraries. They all can fall into two different categories, which is the tokens that are used to access the resources, to get authorized against something, and the tokens that could be used to refresh that access token. And that is the flow that we know is hard to implement on top of the revocation of tokens. So refresh tokens are usually used for users to kind of regenerate tokens without regenerate access token without actually going and authenticating again, providing user credentials. Again, it's a hard topic already enough. So just for you to kind of know that it's there. The tokens themselves could be used in various different ways, not just to authorize and authenticate. And with that, we're going to security, since we already mentioned that a couple of times. You might be familiar with the topic, OWASP Top 10. It is mentioned from time to time in many, I think, Node.js related lectures. I think we mentioned that already in one of the previous lectures, but kind of to reiterate, it's a list of things that cybersecurity experts and security experts in IT are considering currently most violated or most used by hackers to get access to your resources. And we are, as developers and backend developers, we need to know about those security issues, in particular because we do logging and monitoring. So we discussed that in the logs. We do the headers. So we know that on the front end side, we have cross-site scripting things. On the back end, for example, we have broken authentication, as you can see, being the second top thing. And I think it's like the most important one to get right, to get fixed. That's why I'm always saying that if you have ability to use third-party solutions for authentication, you better get that load off of your shoulders, basically, to kind of rely on an already built solution by other third parties. Also, broken access control is also related to broken authentication. So broken authentication, since we've already discussed that today, is all about getting user credentials and then issuing a token that would be used. And that token would have certain accesses or access control, as it says, to particular resources, not just all of them. So broken access control is also one of the issues. The authentication process could be correct. So hackers could be the actual users, but they might get more access than they should have, for example, admin access. And that is a broken access control problem that we need to solve. Again, that's usually a related thing. So how do we avoid those security problems? Apart from using a third-party solution, we do static analysis to kind of get that quality to the top, as we do with every system we write, whether it's a backend or front end. We keep the sensitive information under control, meaning that for those keys, for example, we don't store them, the secret keys, we don't store them in our code, in our source repository. We always use environment variables, and the way that we provide those environment variables is also important, because we can use process.env in our code, but that's actually reading from a .env from our local repository, which is there with our code. So that's also not really a secure way to store your sensitive information. The environment variables should be provided in a secure way from the could be from the CI closed environment, for example. We run processes in the correct as correct users. So since most of the time we deploy our services, Node.js servers on a Linux-based machines, you know that in Linux we can use sudo thing, and that will give not just our terminal, but in general the process where the Node.js application runs a root access, which means that we, in case our other security-related parts fail within our API, and some malicious hackers were able to provide some code with the requests to our API that will run within the process, it might get access to internal system and set up a I don't know, virus or daemon into the machine itself and compromise the whole thing that is running on that machine. So it's also a really nasty thing, and we need that correct user what's that called? Permissions. Check your dependencies for vulnerabilities. That's also one of the topics that is common to backend and front-end development. We need to know possible vulnerabilities in our code. So if we cut corners to get that deadline, to meet that deadline, we need to keep track of possible security-related corners that we cut. Specifically get that thing under issues, under bugs, under tasks, and to keep that control. It's usually done by lead developers and key developers in the team, but in any case, it should be fixed as soon as possible, and we need to at least know where that vulnerability is coming from. We do logging. That's also discussed in one of the previous lectures, but it's not just particular like logging everything that we have. Only the right data should be logged, in terms of we need to provide as many information but as faceless information as possible, meaning that again, if we develop for different countries, they will have different compliance related information, compliance related policies, and that compliance or the field or domain where we are kind of writing a server in could contain some personal information, some PII, all those medical data, etc. In different countries, they are called differently. In general, no one logs those data, those PII data or those sensitive medical information should appear, no matter the level. So you remember that we have even access or debug level or info level. No matter in the level, no data, sensitive data should be in the logs. And so that means that we need to kind of custom solution every time we do logging in any server to make sure that the logger by default excludes the or omits the part that contains that data. It's a really important topic. So a lot of kind of ways to do general security, but for the API itself, security, we have several different ways we can do really good secure API work, and that is first HTTPS. It's becoming a standard to have HTTPS enabled, meaning that we need to have that SSL termination or TLS termination. A bunch of buzzwords thrown into you, but anyway, we need to use HTTPS. It's a more secure version of HTTP. It has almost the same notation in terms of like how developers are concerned, but yeah. Access control should be done correctly so that admins have their own kind of place and have their own access, and that access never crosses the user access. Users won't be able to get the admin access level in any possible way. We need to restrict. Can we redirect to HTTP instead? The way that HTTP works essentially is that usually we first make an HTTPS request to our API. At that level, HTTPS related logic, security logic, if you know SSL or TLS protocol runs, make sure that the certificate is correct, and after that, it terminates that HTTPS connection if we're perfectly right with the details, and it in turn forwards the HTTP request itself. So essentially, we're doing it vice versa. So it's a very deep topic. I don't think we have time to cover that in detail here, and I don't think that I can cover that from the top of my head right now. But one thing to remember, that HTTPS connection should be terminated. And by terminating, I mean certificate should be validated, and then for the request, the original request, its body, its headers, etc., should be forwarded to the actual endpoint by that logic, internal logic that terminates the HTTPS. Okay, so restrict HTTP methods. It is possible to do it by default, like not writing any controllers for that specific endpoint and HTTP verb combination. But sometimes we need to actually restrict the methods. For example, we can allow all the users of our system to get the resource, but only admins to post or put the resource. So that's what the restrict HTTP method means. We need to do input validation, and it covers most of the XSS or cross-site scripting attacks, meaning that we don't trust front-end in any case, just the default. We don't trust our own front-end, and that allows us to validate everything that comes into our system before we actually proceed and work with it. And it's usually done in some kind of middleware. We do error handling. Again, we don't want malicious hackers in the rage that they couldn't access some resources, shutting down our own servers. So we don't want that. We do error handling. We gracefully shut down and restart the service, logging what happened, logging all that rage cups typing of the hackers. We do audit logs. Audit logs are logs that could be enabled to provide additional information of how the request flows through the system, giving usually a bit more details of what happens at every stage than usual logs. We set security headers, and there are special headers that we need to know as backend developers that we need to set always, and that relates to course that we'll discuss in a moment. And again, sensitive information, HTTP requests should be kind of omitted. We should not log it, we should not handle it in any way, and we need to build our API in a way that sensitive information is never in the request itself. Okay, that's kind of a lot to do. And luckily we have some things that are already written for us. And one of the things some of you might be familiar with from your front-end experience is Helmet. It's a bit different Helmet that we know from front-end. We know React Helmet, Vue Helmet, etc., etc. That is all about metadata, meta tags. And Node.js case, Helmet is a library that handles most of those headers that we need to know, leaving us in a peaceful bliss writing controllers all day long. So essentially, when we use Helmet, we don't think about security-related headers. We don't think about caching anymore, setting all those cache control headers. We don't think about powered by and the way hackers to debug our or reverse engineer our API just by making requests to it. At least we limit their ability to know that it's written with Express, and much more. There are, I don't know, 15 or 18 different headers that it sets, and to get the default setting for all those headers, you just require Helmet and then app.use Helmet, and that's it. That's all you do. And it's usually app level, app scoped. So for the entire application, for the entire web server or application server, you just set a bunch of headers that will be automatically handled by Helmet. And that's always good. And among those headers, we need to at least know the basics of CORS. So what is CORS? CORS, as you know from your front-end experience, or might never encountered, but CORS is a policy, and that policy is not related to our application server. It's not related to our JavaScript code in the front end. It is completely related to browsers. So browsers control CORS, And that policy inside every browser says, hey, if some website tries to access some API at a different domain, restrict it. So CORS is all about browsers being a bit more controlling than it needs to be sometimes. And browsers using CORS policy, they are not allowing any JavaScript on front end to access any backend on server, except when the server says it's okay. And we have two flows. For example, simple request flow and complex request flow. Some of the HTTP request methods, like I don't know, get, headers, in some cases post method, they are running in simple request flow, meaning that when you send the request from your code, there will be one request and one response. So that's what we see on the picture: one request and one response. Between browsers and actual servers, there will also be one request and one response. And you will see one request and one response in your network tab. And that's how you know it's a simple request. You do the request and you get the response. That's it. No other requests are coming at this point. And as you can see, we're setting, hey, I want to access the javascript.info API. And my domain is javascript.info. Hey, server says, hey, I don't really care what origin is there. Or if it's my javascript.info API and frontend is accessing, and that's actually javascript.info frontend, I allow it. And then all the headers are forwarded back to the application with all the response. The non-simple or complex requests is usually the one that it's usually the one when you see more stuff in the network tab than you originally expected. So you expect, again, you make a request and get the response. So you make 2 arrows, but instead you see lots of them. And that's where the browser decides, hey, that's a bit more than I expected in terms of your request. That could be a post with a body to some different domain or something. Browser, to kind of force the CORS policy, first goes and asks the server, hey, do you know that website? Do you have any mention in your headers about the method, the headers that should be sent, and is it possible for that website to access you? And the server replies, yeah, it's okay. Here's the methods that I expect, and there is the headers that I expect, and here's the access control max age that I send to you to use internally. And then if that was successful, browser says, okay, here is the post, the original post request from that website. And server responds, hey, I know that website, or I don't really care about the websites I'm getting requests from, and the whole process is successful. Otherwise, whenever I do options, whenever browser does options requests to the client, if a particular application on a particular domain has access to a particular server, and that server says, hey, I don't know that domain, at that point, CORS is applied. And that whole complex process is just so that developers of front-end applications, like websites with just HTML, CSS, and JavaScript, or some kind of React, Vue, Angular applications, don't get too much of the freedom when it comes to data from servers. And browsers, by enforcing that, shift the responsibility of whether to allow something to happen or not to the actual servers. If that doesn't make sense, whenever you encounter a CORS problem in writing your front-end application, or writing some logic that accesses your own application on the server, whenever you encounter that annoying red thing in console of your browser, know that you need to go to your server and set specific headers to kind of note that, hey, I allow this method, I allow this headers, and I allow this origin. If you don't have access to the server, if you're not the one who's writing that server, who's maintaining that server, the only option where you can access that is when an access control allow origin is whatever, meaning that star asterisk thing. If it's something specific, you won't even know that. So if you don't have access to servers, you need to check the documentation for that particular API to see how they handle CORS. If you have access, you just simply return a set of specific headers to get rid of that annoying CORS red thing in the console. And that's all there is to CORS. In short, it's a specific security, an additional layer of things to be done by poor developers to get the front end on one domain to work with a backend on another domain. And I think that's it for today's lecture. Feel free to ask any questions. I know that was a bit more for one lecture, but authentication, authorization process, and security is not an easy topic for anyone. So input validation question. Okay. Are you going to type that or unmute yourself and we can discuss?
Yeah, it's maybe better to go by voice. So if input validation is that obligatory on backend, does it mean that input validation is somewhat optional on front end, or we should do like validation twice?
If you talk about, so in general, there is a rule of thumb for any backend, whether it's a Node.js or Java or any other backends, is that you never trust front end, whether you control that or not. So you start with validating your backend. Then there is a term validation on front end, but that's usually about whether someone fills some form fields or not. So on front end, validation is not necessarily about security, but more about not making requests when the data is not there yet, or data is not valid in terms of some business logic, that thing. So kind of to reiterate, Node.js being a backend, you need to always do validation of any requests, of any data that comes into your application if you want to be secured. So you don't trust the front end, even if you control that front end. On front end, doing security-related validation is optional, yes, because it might take some computational power, because, I don't know, running some hashing algorithm and checking if that hash is okay is a bit too much for some of the browsers. But validation on front end is related more to the data itself being correct in terms of the business logic.
Can you give an example of security validation, as I'm not getting that point?
Security validation on where? On the front end?
On the back end.
For example, you have a front end sending you a feedback form. For example, you have some email field on the front end and a text area. And in the text area, you expect that users will be inputting some kind of text complaints, etc., etc. You do that validation on front end to make sure that before user clicks on the send button, there needs to be at least something written there. Otherwise, you show that form validation errors, red things on front end. But when some data is inputted already and user actually hits the button, the request is sent. It could be a simple post request with that information, email and text area. And on the back end, you probably store the whole feedback form for a particular user to get the analytic, etc., etc. So before storing that data, you make sure that email is actually an email. So that's one of the validation, and it's a business logic validation. And then, as a second step, you make sure that whatever text is written in the text area and is sent to your API does not contain any JavaScript, any strange notations, any code, etc., etc. And this process of validating that text area will be called sanitizing. And sanitization is the process of making sure that text is just a text. It's not an executable line. You never eval of that text area. There is no SQL related things, because SQL injection, as you've seen on one of the previous slides, SQL injection is the top issue with most of the backends. So that's what I call security validation of user input.
Okay, now it's much more clearer.
Okay, and usually we didn't cover that in this run, but usually when we discuss databases, SQL, NoSQL, etc., etc., the way we work from Node.js with those databases will revolve around additional libraries. They're called ODM and ORM. It stands for Object Relational Mappers and Object Document Mappers. And those libraries are there to provide an additional layer of security. So they will make sure that even if we have that SQL code in the text area and we missed that thing, those libraries will ensure that right before we submit the data to our database, there is no that text, or at least that text is raw in terms of it won't be executed by the SQL engine. Yeah. Like that.
And speaking of sanitization, I guess there should be external libraries for doing that.
Yeah, sure.
And is it a rule of thumb to check every text input or numbers as well, like selects, etc.? How this should be handled?
You usually, again, as with most of the security-related stuff, like authentication, authorization, also you do rely on external libraries, because you ship the responsibility on them, and if anything happens, you just blame them. But yeah, you need to do validation, at least the basic one. So wherever you start a new project, a new API, you by default you install some validation libraries like Joy, for example, to do the validation, and you at least make sure that the business side of the data is correct. And then at some point you will be asked by security compliance team to do the additional layer of validation, making sure that security related things are not included in your input. So at the end of the day, you will end up doing both, and business related on front end and back end, and security related. But security related validation will be most likely be handled on the back end, because again, that's too much to ask from front end applications.
Yeah, okay, thanks. That was kind of clear. And another one question is about authorization. So if it can be displayed in a couple of words, let's say user A and user B were authenticated, but how do you actually control that user A has access to the resource and user B does not?
It depends on the way you authenticate, you handle authentication. So, okay, let me go back to the actual JWT, for example. So in JWT case, you can encode the level of access in the actual payload. That's not secure in any way, but that's one of the easiest to explain. So for example, it has the admin true. That says like B has access to something that A has not. That's one way. Another way, more secure one, is to have some ID, for example, like sub ID, that would be in turn somewhere in the logic that will verify your user, will actually check additionally if that user has any external access control related rules. So that's a separate topic and separate flow. So usually it's at the token level or the security level. So in JWT, it's payload could be, or an ID that you'll in turn compare to some registry of users to find which ID corresponds to admins and which to regular users. And if you are accessing something that could only be accessed by admins and that ID is not present in that admin registry, that's where your logic will say, hey, nope, you don't have access to it. In Passport, it's a bit easier, but in general, it's up to you to organize that authorization. In short, but different tokens will be issued to different users, not just on user basis, but on access basis also.
But like, did I got you correctly that in the end for authorization, you will need one more middleware function to make sure that user is authorized for that resource?
Could be. Again, authorization it's not. Authorization does not cover access control completely. Authorization, for example, I can include this check token on some of the endpoints. And in that check token function, I will be specifically asking that the one who's accessing this endpoint is actually an admin. But even before I get to this endpoint, I can have a application level logic that checks whether user is authorized to at least access the application itself. So it's in short, there will be a number of middlewares that will sprinkle across your application to have different access. But again, it's not always about going to a database, comparing the IDs of admins and basic users. It could be at the middleware level. So some of the middlewares will be covered with additional middleware, or some of the endpoints will be covered with additional middlewares to check access, some not. And that's actually how you do public-private APIs in one application. Some endpoints you don't cover with additional checks and some you cover, and that's how you get the private-public facing APIs.
And okay, here, instead of a comment where you pull user from database here, is that a good place, for example, to add username or some user information to like request properties?
Yeah, sure.
Ah, okay.
That's just a callback that you give to JWT to execute for you. So that's completely your logic. And the authorization, the basic authorization, will be checked here. So when you provide the token, it will not even go anywhere if the token itself is wrong, so that this endpoint has been, someone has tried to access this endpoint and the token is not correct. If you think about it, authorization different from authentication with just a token. So authenticating against something, you don't have a token yet, but authorization is all about tokens. So you can imagine that someone may have obtained some token, and if you want to have, for example, admin token, and if you want to make sure that that user who obtained your token is actually an admin, you go and input some logic here.
Okay, yeah, seems that I'm confusing authorization with an access control. That's
Yeah.
my problem.
Yeah. Yeah, so access control is a generic name for anything related to kind of like dividing users into different groups. And it could be handled in various different ways. It could also be part of authentication authorization flow, but it can also be part of some business logic. So, yeah. Okay, any other questions? Okay, cool. So at this point, I conclude our series of lectures. It was nice to have you guys around, and hopefully you had a great time learning about Node.js and all the intricacies. The program was covering just some of the topics that there are in the Node.js community, Node.js ecosystem. We didn't cover any Dockerization, we didn't cover NoSQL, SQL, etc., etc. So there are plenty of topics that you can cover yourself, but I encourage you to do that because Node.js and backend in general is a very interesting place if you are not allergic to all those tokens, authentication, authorization, nitty-gritty details. All right. So thank you again for your attention. And I see you, I don't know, sometime. Bye. Oh, okay. You want to ask one question after translations? Ah, okay. You mean the recording stops? Okay, let me stop the recording. Okay.